Hello everyone. This is a video lecture for pre-calculus. We're going to be doing 6.5 trig equations. That means we're going to solve for x. Woohoo! We get to solve for x. Yeah, woo! I have to warn you right now that this is going to be a big video. That last one was small time. I might even break this up into like two pieces depending on how things go. And there's a whole ton of new concepts that are going to happen. They're not new, but they are a little differently approached. Okay, but at least we're going to solve for x, which is super happy. Here we go. So it says cosine of x is equal to square root 3 over 2. That's going to be a positive. Just keep that in mind. Where on the unit circle are you seeing the x value? Not because there's an x right there, but because it's cosine. Cosine is x value on the unit circle where it's a positive square root 3 over 2. Right here at 30 degrees and right here at 330 degrees. I can, again, I'm not going to do this every time, but I want to like prove a point to you. When you're looking at your unit circle, you're looking right here, and you're looking right here, okay? At the x values, that's it. Cool. So those are my answers. I'm done. No problem. Let me just go ahead and tack those in. Of course, radians, right? So pi over 6 radians, 11 pi over 6 radians. Awesome. There we go. Oh, what? What did you want? What is it? And I'm telling you, in my math lab, get it wrong 3 times and see what they're giving you, because it is actually different. It's very different. So here's your pi over 6 plus 2 pi n, comma, 11 pi over 6 plus 2 pi n. And that's their answer. Ding, ding, ding. Okay, what are they talking about? So if you read the directions closely, they'll say to use 2 pi n, kinda. I have some notes here. It says, just get all your answers and then add a 2 pi n. The reason why it's 2 pi is because the period for the cosine is equal to 2 pi over b, basically. So just, there you go, 2 pi, essentially, for the sine and the cosine. N is this number, it's just a number, integer kind of thing, because the concept is that, yeah, we have these answers here at 30 and 130, right, on our first revolution. But what about, this is 360, isn't it? So what about 390? Isn't that it also going to work? And then if I go all the way around, I don't know what this number is. It's going to be like 600 something crazy, 700. Actually, I think it's maybe 690. Yeah, I think it's 690. I can't remember. But doesn't that work? Yeah. Hey, what about like negative 30? Does that work? Yep. What about negative 330? Does that work? Yep. All of those work. So it's kind of like saying all of the numbers that ever could like co-terminate at those original points, okay? So that's the goal for what my math lab wants. We just basically find the answers, 2 pi n, call it a day. Okay, well, I can do that. That's not too bad, right? Okay, tangent. Tangent equals 1. That seems so easy. Remember that this is a slope, okay? And on your unit circle, you wrote down your slopes, right? Little m's. Slope is equal to 1. Here, slope is equal to 1. Again, the reason why is because it's square root 2 over 2 over square root 2 over 2, and they cancel and make a 1. Da-da-da-da-da. Cool. So, yeah, 45 degrees. Awesome. And at 225. Well, you're not going to catch me. Those are supposed to be radians, right? So, yeah, we got pi over 4 plus 2 pi n. And then I have 5 pi over 4 plus 2 pi n. Awesome. You are correct. You are correct. My math lab says you're wrong. Why? Why is it? Well, isn't it obvious that it's only a pi n this time? You know what? It's because the period for tangent and cotangent is pi over b. Again, pi. And so this is only for tangent and cotangent. We're using a tangent, so there you go. Well, why do I only have one answer? Because pi would get me back to this guy, right? I start at 45, and then I add pi. I add 180. There you go. And then I add another 180. Or I can subtract 180. Whatever it is, this kind of encapsulates both answers. You just start with one, and it can kind of do both. So annoying. But you are correct here, okay? I'm serious. That's correct. It's just that my math lab wants it most simplified. It's okay. Breathe. Breathe. It's okay. It won't be the last time today, truly. So, oh man. I'm not laughing because it's so mean, but it is mean. It's mean to you and me, okay? It's mean to me. So, I've got cosine of 2 theta is equal to a positive square root 3 over 2. It doesn't have a positive sign, but I'm making it there because that's important. You got to keep that in mind. Okay. So where could this happen? Well, again, if you think of this as just your angle, don't go and try to do crazy math right now. Just do an angle. It's right over here at, again, the 30, and again at the 330. Cool. And so I know what to do. 2 theta is equal to pi over 6 and also 11 pi over 6, right? Radian stuff. And all this other stuff. Oh, 2 plus 2 pi n, right? Oops. Mean. Sorry, I can't contain myself sometimes, okay? Just hold on. Okay. Now, there is a tiny bit that we need to do here to make this thing work. Okay, I see what's going on. This is actually legit here. What I'm doing here is legit. It's not. Oh, it's okay. It's totally legit. It's fine. This is great, man. This is great. So, I want theta, like just single theta. Notice I chose the 2 theta is equal to all this stuff because I'm trying to be good. I'm saying that whatever's on the inside, right? X, theta, 2 theta, don't matter. There you go. So how do I get theta by itself? Well, you divide by 2. Sounds easy enough. So now I've got pi over 12 plus pi n, and then I got 11 pi over 12 plus pi n, right? Because the 2's are going to cancel there. This just combines and whatever else. Cool, man. Cool. That's awesome. Whoa, it's so mean. So mean here, guys. I'm so sorry. I'm so sorry. So, get it wrong 3 times. Totally. I totally support you getting it wrong to see what format they want. And so now let's talk about this. So mean. That's your answer. Okay. What just happened? So if you read the fine print on this problem, they only want the first revolution 0 to 2 pi. And they'll have this kind of, interval notation, I guess you can say, to kind of restrict the domain. Okay, that's fine. Yeah, I still don't understand what's going on. So basically, they're trying to say get rid of the 2 pi n part. They're trying to say that. Like, you never needed that. All right. And that makes sense now that I'm looking at it. Look, I got 2 of the answers. But where do these other 2 guys come from? Okay. So remember how we found 30 and 330, right? That's cool. We did it. But didn't I also say that this could be 390? Yeah. And if I kept going, couldn't this also be, I don't know, what was that again? 690? Something like that. I don't know, man. I don't know. It's a lot. So what we need to do is, from the beginning, 2 theta is equal to the pi over 6 and the 11 pi over 6. And that was cool, but we're going to keep going. We're going to keep going in anticipation of the divide by 2. And again, I'll fill you in on all of these things in just a second. Just keep rolling with me. So This is 13 pi over 6 is the next one. And then, again, think of it like 11 plus 12 is going to be a 23 pi over 6. Okay, and you can kind of see these right here. I'm just going to the next one. So if this right here is 12 pi over 6, right, in that 2 pi, then what's one more is 13 pi over 6. That kind of stuff. If this right here would have been 24 pi over 6, then what's right before it is 23 pi over 6. You'll get used to this as you keep going. There's not a great answer besides just kind of seeing how it's supposed to work. Okay, you can use a calculator and you do the decimals, but ultimately you're going to have to know a little bit more about this. Okay, focus on your unit circle. Now, I'm going to divide by 2. And the reason why I had to keep going was because my answers now, all of these answers, here, you know, I'm not going to rewrite them. I already have them. They're right there. There you go. There's your answers. The reason why I kept going here is because my result now all has numbers that are from 0 to 2 pi, okay? Notice that 23 over 12 is really close to 2, but it's not quite 2, so we're okay. Now, where are these angles ending up? Just as an example, well, pi over 12 is like 15 degrees or something, and 11 pi over 12 is like right here, and then we got right there, and then we got right there, kind of. Not a perfect graph, but the point is that we had this and this twice. Okay, so we had it once, twice, and when I cut them all in half, going backwards, I guess, this is what I result in. So, how do you, right, because you're new to this, how do you know when to stop or what to do in every time? And so I'm going to give you some hints here, okay? I don't know. These are way unofficial. So if you have like a 2 theta, then you need to go 2 revolutions of answers. Okay? So if you have like a 3 theta, how many revolutions? 3 revolutions of answers. And you go around a board as many times as you have this. Okay? If you got a 5, you're going around 5 times. You're going to have like 10 something answers. It's going to be crazy, but that's just part of how it works. Okay? Whew. Yeah, I know. This is just, it's wild. But let's just keep going. You'll see more and more. I can't just stop and pause on something forever. We need to keep cruising and see how to approach these problems. And the more you practice them, it will get better. Okay, right now it's really tough. I'm serious. This is some tough stuff. Okay, so tangent of 3x is equal to 1. I've already told you how this works here, okay? So right here and right here are my answers. I got 45 and I got 225. Awesome. Notice that both of those are from 0 to 2 pi. But we have a 3. So let's like understand this here. I got pi over 4, that's my 45 degrees. And then I've got the 5 pi over 4, which is my 225 degrees. But I got to keep going. How many times, right? So there's 1 revolution. Now I got to go again. So if this here, if you're talking over 4s, this is 8 pi over 4, because that's 2, isn't it? And then I'm going to go 1 more, so 9 pi over 4. And then down here, again, you're trying to do a little bit of math here. 8 plus 5. Do you see? I'm going to use a different color to show you. So from here, there's a 1. And so from here to here, I said plus 8, right? And so that's what I'm going to do right here. I'm going to say plus 8. So 8 plus 5 is 13. So now my next number is a 13 pi over 4. Okay? Again, the 8 is just kind of like a pattern here. It's that 8 over 4 business right there. Well, there's my second revolution. Now I got to go to a third one. And so I'm going to do 9 plus 8 is 17 pi over 4. And then I'm going to do 13 plus 8 is 21 pi over 4. Whew! All right, so there's my third revolution. 3 revolutions, 1, 2, 3, got them all listed out. Here we go. Divide by 3 so I can solve for x. All right. So every one of these is going to be just kind of crazy. Let's go. There's a pi over 12. There's going to be a 5 pi over 12. Nothing's reducing yet. 9 pi over 12 cancels to make 3 pi over 4. And yes, my math lab wants you to reduce it down. 13 over 4, nothing cancels. So 13 over 12 technically. 17 is a prime number. Nothing's going to cancel. 21 over 3 makes a 7. Pi over 4. I'm just reducing these things down. And yeah, yuck. There you go. That's how you do it. You got this. You do got this. You do. It's just crazy problems. All right, let's just make this even crazier. I got tangent of x over 2 is equal to negative square root of 3. And they say, again, only look from 0 to 2 pi. See, I'm looking for this stuff now. If they don't have this, then you have to do the 2 pi n business. So, watch out. Okay, so tangent. Tangent's equal to this guy. Remember, this is my slope. I'm saying my slope is equal to square root 3. And you totally wrote that down. Right here, my slope is the negative square root of 3. And right here, my slope is the negative square root of 3. This is at 120 degrees. And this here is at 300 degrees. Okay, so x over 2 is equal to... This is just so funny. All right, this is hilarious. You're going to love this. You're not going to love this. So this is 2 pi over 3. That's my 120. And then I've got 5 pi over 3, which is my 300. Okay, so how do I get x by itself? And I'm going to ask one more thing. This is a full revolution, right? How many revolutions do I need to go? How many revolutions do I need to go? Half of a revolution. Keep that in mind. All right, so I'm going to multiply by 2. Multiply everything by 2 over here. And so they cancel. And so I've got, now the 2 is going to go into the numerator, 4 pi over 3 and 10 pi over 3. Nice, nice. Uh-oh, they said from 0 to 2 pi, and this is too much. Remember, 6 pi over 3 would be a 2 right there. This is too far. This is your only answer. How many numbers, how many answers originally did you have to have? Half of a revolution. Because it was half. Do-do-do-do-do-do. I'm telling you how to get these problems, okay? I'm not trying to shortcut you or make it, like, weird. This is legitimately how you do these problems. And I might be acting a little funny at times. But in the end, this is how you do these problems, okay, guys? This is how you do it. So 0 to 2 pi. Again, so that's nice. Notice that this is, again, a positive, and I got something really weird here. I mean, this is an angle, okay? I don't know how to make that happen yet, but hey, you know what? That's not my focus yet. I need to work on this guy. So positive square root 3 over 2 is over here at the 30 and the 330. How many revolutions do you have to go? Probably 2 of them. Ignore this for just a second. It's okay. So 2x minus the pi over 6 is equal to, and so we have a pi over 6, 11 pi over 6. There's 1 revolution. And then we have the next one, which would be a 13 pi over 6 and a 23 pi over 6. That's the second revolution. Okay. So we did 2 revolutions. I hate these problems sometimes. I'll show you. Just kind of chill out with me for a second. This is hilarious. Oh, man, I'm not playing with you, man. I'm just doing what I would do. What would Chad do on this problem? I would be doing what I'm doing. So, I'm going to add pi over 6 to every side. I don't know, whatever you want to do there. So, I've got now 2x is equal to, so pi over 6 plus pi over 6 is 2 pi over 6, or pi over 3. And then I've got 1 pi over 6, and that makes 12. 12 pi over 6 is 2 pi. Okay, and then right here I got 13 plus 1 is a 14. 14 over 6 is 7 over 3. Is that what I got? Yes. And then finally over here you add one more, you get a 24 over 6, which is a 4 pi. Okay. Whew. Divide by 2. I'm just doing what Chad would do. And so now I got my pi over 6. I've got these two cancel, make a plain old pi. I got a 7 pi over 6. And then I've got a 2 pi. Okay. Yeah, it's wrong. This is wrong. Because if you notice, it's from 0 to 2 pi, but look at my interval notation. I got the square brace bracket thing. I'm including 0, but not 2 pi itself. So I can't use the 2 pi. This is definitely out, okay? It's close, but I can't use it. So those three, do those work? Again, what is the answer? Let's just skip ahead and get the answer. They have a 0 in there. Yeah, they have a 0 in there. Oh, this is so frustrating. I'll show you. So, oh, there's a pi. I'm sorry, I forgot the little pi in there. Okay, here we go. This is so frustrating. Here we go. You ready? So that's your answer. How do they get the 0? Well, if you go way back, right here, to what we were doing, I need to also write out answers over here as well. Okay? So let's do that step right here for just a second, okay? In anticipation of having to add stuff, I'm going to say a negative 30 degrees is also a legitimate answer. And then, of course, the positive 30, and then the other stuff that we all had here, the 330 and da-da-da-da-da-da. Okay, so when you add pi over 6 to all these guys, right, to every single one of them, there we go, what happens is these guys make a 0, and then we have our 2 pi over 6 and our 12 pi over 6, da-da-da-da-da. Okay, and then that's equal to 2x, and then I divide by the 2. I know I'm only skipping some of it, but what's 0 over 2 is a 0. And then all the rest, just as you figured here, pi over 6, pi, that's fine enough. Okay, so yeah, that 0 is included in your answer. How would you have known to do that? Well, you know, as a human, I don't know, man, but as a robot, you, of course, were thinking of using negative numbers and positive numbers all over the place. Yeah, a robot would also have a negative pi over 11 pi over 6, just in case. And they would probably have some, I don't know, 101 pi over 6, just in case. Whatever, man. I mean, it's technically you're supposed to list out every single possible thing ever, divide by 2 everywhere, and then see what matches up. That kind of stuff. It's silly. It is, I know. But that's how it works, man. That's how it works. That's a gotcha moment. That's why I'm doing it with you. Remember, I'm not doing every single homework problem, am I? So I'm doing this because I know that it's troublesome. Okay. Oops. Okay, there we go. So, solve for theta. Now, this is a quadratic. I'm going to write quadratic. I'll just put quadratic. What is a quadratic? Well, it's kind of like saying 2x squared plus x minus 1 is equal to 0. And so we're solving for x, kind of. And that's totally fine if you want to do that. I don't mind. I'm looking ahead. How many more pages we got? A lot. So it's okay. So solve for x on this. I need to factor it, and I'm hoping that you're getting better at factoring at this point. And so the 1 is definitely going to be there. And notice that I'm going to need a positive and a negative. And again, you can FOIL this out, and you'll get this answer, and everything should be fine. Just learn factoring even with these 2's in the front, So I need to solve for x, I guess. And so x is equal to positive 1/2. And here x is equal to -1. But the thing is that it wasn't x, it was sine. So I'm saying sine of theta is equal to a positive 1/2. And sine of theta is equal to a -1. Now, where do these happen? So I'm looking for the y value that's a positive 1/2, and that's going to be over here at 30 degrees, and over here at 150 degrees. On this side over here, so my sine is a y value straight down at 270, I guess. That'll work. Okay, so those are my answers, but now I just need to put them all into radians, and then we're done. So pi over 6. Then I got the 5 pi over 6. And then I have the 3 pi over 2. And that's it, right? No tricks? No divide-bys? Nope, not this time. Not that time. 6, 5, 51. So I've got 9 times the secant squared x. I quit. No, I'm just joking. It's like, where does it end? But in a funny way. I mean, we're all just laughing here, aren't we? You're not laughing? Okay, I'm sorry. So, anyways, let's solve. I'm gonna move this 12 over, and then I'm gonna divide by the 9, and so I've got secant. Ooh, let's make that a little bit better. Secant squared x is equal to 12 over 9. Which reduces down to, what, 4 over 3? Yeah. Square root both sides. Remember, when you square root both sides, you have to have a plus a minus. Very good. And so square root of 4 is a 2, and then you have a square root 3. But secant is not something I'm used to. I want to use a cosine. I'm going to flip it, basically. So what does it look like to flip this one? It looks like it's the square root of 3 over 2. And it's plus and minus. That's the sound effects. I just made that one up. Where are my x values? Again, because it's cosine. Where are my x values equal to plus or minus square root 3 over 2? Here at 30 degrees. Over here at the 150. Down here at the 210. And here at the 330. Those are my answers. Now let's put them, this is x, not theta. Now let's put them into radian mode. Pi over 6, 5 pi over 6, 7 pi over 6, 11 pi over 6. That was such a fun problem. Now, let's move on to the next problem. Is this making you sleepy? Are you happy about math? I gotta have some humor in here, man. I got to, because there's this, it's like relentless. This thing just keeps happening. So this square root 2, it ends right there. The cosine's not inside. Not. Okay. So this one's a little different because I have the sine of 2x and then I have a cosine of x. You can't mix them very well. So I'm going to reduce this down with a formula. Sine of 2x is 2 sine of x cosine of x. There's actually one that I've memorized. Okay. Be very careful. I'm very serious. Every time in my mind is what I do. Bam, done. Keep moving. And that will get you the wrong answers. No, 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 no. You have to take these and subtract them to the other side, and then you're going to factor out the cosine. I have made this mistake so many times that I have to tell you. It's like a public service announcement here, okay? Don't cancel. Okay? Don't. No canceling. You will not get the right answer. Okay, that was all I could say. Now we're moving on. So I move this over by subtracting it, and then I factor the cosine out to the front. What this does is it says that cosine of x is equal to 0, or, do you see the answer here? Sine of x is equal to, I'll wait for it, positive square root 2 over 2. That's right. When you move this over, you're adding it to the other side, divide by the 2, that kind of thing. Again, we're just solving for stuff here. This is just factors. Very common. I just wanted to show you, hey, this is not too bad. So where's my x value equal to 0? Well, it's straight up at 90 and straight down at 270. Where is my y value, a positive square root 2 over 2? It's over here at 45 and over here at 135. Awesome. Now I just write them all down in radian mode and call it a day. So pi over 4, pi over 2 for my 90, 3 pi over 4, that's the 135, and then finally 3 pi over 2 is straight down, and then we're done. Whew. Are we there yet? Are we there yet? No, we're not. Next one. It says sine of x is equal to a negative 0.5112. And again, they say, hey, find everything between 0 and 2 pi. So I want to just clarify something here, if that's okay. This is 0 until about 6.28. That, it'll keep going, but that's just roughly what's going on. Okay, remember that sine is the y value? Sweet. So the y value is supposed to be negative, and it's, I don't know, half or so, just there. Just stick some stuff there. No clue where this is. No clue, but that's what we should be looking at. Negative y values. So how do we actually get those real angles? Well, good question. You're going to use a calculator. Find the arc sine of the negative 0.5112 in your calculator, and you get negative 0.53658 radians, and you're like, oh yeah, that made so much sense. Where is this thing? Okay, just calm down. This is 0 degrees, 0 radians. This is 1.57, and this is a negative 1.57. Notice we got a negative, right? So it's like down here somewhere. Okay, negative 0.53. No clue. No clue. But guess what? Guess what? This is this. Yes! Yes, they're the same. Ah, there's one of my answers. Not really, not at all, actually, because we need to go from 0 to 6.28, and this is a negative. That does not fit in this interval. Okay, so what we need to do in order to get it there is, first off, just add 2 pi to this. That's the quick way. But to get over here, what we're seeing is that this is a small negative number, but what if I made that a positive? And then I could see this as like an acute angle. So to be able to get this one over here, what we're going to do is pi, which is right here, there's pi, and I'm going to add that small acute angle, like the positive version, essentially, okay? Okay, and then on this side, I'm going to say 2 pi minus that original 53658, and then we go to the calculator to get our answers. So here we go, 3.67817, and over here we got a 5.7466605. Okay, awesome. There it is. There it is. Those are the answers that you put in, comma separated, in the homework. I'm not exhausted of these things. I think they're kind of funny, but I think they're funny on like a mean level. You know, they're not like simple funny. They're just mean funny. Okay, here we go. E to the cosine of x is equal to 2.2. Solve for x. I mean, really? What is this? I've taught pre-calculus many times, okay? I have. I've been teaching for over 15 years now. Um but I've never seen this. I mean, I have. I've seen it in like calculus or something, but this is just wild, man. Um, so okay, it's okay. Let's get all serious now. I need to solve for x, man. How do I get rid of that e? What do I do? What do I do to both sides? You what? Did I hear that? ln both sides. That's ln both sides. Yup. So you ln e cosine of x is equal to ln of the 2.2. Sweet. And these guys cancel. Ay, ay, ay. There you go. Okay, so what's, you know what? I'm not even going to ask questions. Like, what is ln 2.2? I'm not going to ask questions. Actually, I am. I'm going to ask questions. If you go to the calculator, it's 0.7 88457. Now, that's a ratio, okay? And it's positive. Keep that in mind. My x value, because this is a cosine, is a positive value. And so that means that we're somewhere over here and somewhere right there. I don't know where. I don't know what that answer is, but it's somewhere over there. Well, what I did last time is I did the arc cosine to be able to figure out the answer. True. Now, there's a big problem here. You could, like, round. You're rounding this, and then you're rounding this, and it starts to round of a round of a round, and it could get bad. It could start to not work. Like, you might even get, like, one answer, but not the second one or something weird. So try to just keep as many decimal places as possible, okay? So that's my radians. Everyone knew that. Of course it was 0.66 radians. Duh. And that's actually true. That is this right here. Again, remember, this is 1.57 up here, and this is 0. So 1.66 is somewhere around right there. There you go. So that is actually one of your answers. And then a negative 0.66, right? But we're not going negative. We have to go 0 to 2 pi. So we have to find that other answer. So here we go. One of my answers is the 6624999. Okay. Then the other one is 2 pi minus that amount. 6624999. Okay. And did I get that? Did I actually write that? Oh, I did write it down. Okay. Which this guy right here, I'm just going to write it down for you, is 5.6 0 2 6 8 5. I don't know. Round to whatever decimal places they want. All right. Do you think that this could get any worse? Do you think? No way. Not at this point, man. I mean, no way, right? ln of the absolute value of sine of x is equal to ln of the absolute value of the cosine of x. Now, pause. When I did this problem the first time, I messed it way up. Do you know why? Because I just canceled ln's and call it a day, all right? Sine equals cosine. Yay! What? You do have to cancel. But it's the absolute value of sine is equal to the absolute value of cosine. Oh, please don't throw something at me, please. So mean. So, okay, yeah, that's fine. Okay, so how do we encounter this, right? What do we do with this? What does that mean? It means that there's a plus or minus sine x could be equal to a plus or minus cosine x. Or maybe I should put like minus plus or something like that. In a way here, I'm saying that any sine And any cosine, as long as they're the same numbers, then it's okay. And let me give you an example. This is super easy examples. What about square root 2 over 2, square root 2 over 2? Are those the same? Yeah. Yeah, those are fine. What about over here? Negative square root 2 over 2, square root 2 over 2. Are those the same? Yes. I don't care about negative, positive. I'm looking at the numbers. So yes. What about down here? Negative and negative. Yes. What about down here? Positive, negative, negative, positive, whatever. Yeah, yes. It's great. All the 45s. All the 45s are your answers. But see, if you would have left it like this, you'd have only gotten 45 and 225, and that would have been it, because they would have had been the same SIGN sign. But that's not the case. Okay. I know. Just mean problems, man. I get it. I get it. Okay. It's a 7, isn't it? 7 pi over 4? Yeah. Yeah. Okay, cool. All right. I have 2 GeoGebra problems, and then we're done. Okay, we're like so close. So number 21 is a GeoGebra problem. I just label them number whatever on the homework. It could change. I don't know. I'm just writing down whatever I have. So negative 4 cosine of theta minus the 0.4 is equal to negative 1. And again, this is a GeoGebra problem, so it's a little weird. They say theta 1 is equal to something, theta 2 is equal to something else, and then it says, I mean, that's just what it says. Okay, I'm just writing down what it says, and then it says, hey, 0 to 2 pi for this stuff. So only 0 to 2 pi. Okay, what are they asking for here? Well, instead of writing your answers with a comma separated, like pretty much like what we've been doing in my math lab, they're just saying write them in individual boxes. That's all it is. So we got 2 answers, and we're expecting that. But we've been having multiple answers all this time. I'm going to add the 0.4 to both sides. And notice that we're going to still get a negative, but it's a negative 0.6. When I divide by the negative 4 on both sides, I have, what do I have? I have a positive now, 0.15. Okay. Now, of course, what we're going to do to find theta is the arc cosine. Especially when it's like a decimal just kind of hanging out. Got to use the calculator at some point. 1.420228. Again, that's radians. So what does that mean? Well, again, if we go back, I'm looking at the cosine is a positive x value. And where are positive x values? They're going to be here, and they're going to be here. And so what I found was 1.42 is right here. And how do I know that? I'm going to just write the 1.42. How do I know that? Because right here at the top is 1.57. So, we went up some. Well, now I need a negative value, right? But, of course, we can't do that, so it's going to be 2 pi minus the 1.42. And again, I use the calculator to find it. Is 4.8262957. This is an answer. This is an answer, okay? Now, I'm going way crazy on my decimals because 6 is safe. Keep that in mind. I'm not doing this in the calculator. That would not work. I'm doing 2 pi minus this in my calculator, okay? That's what I'm doing in my calculator. Okay, glad we could talk about that. All right, last one is another GeoGebra, number 22. As far as I have on mine, it says write a trig equation. Uh-oh. Write the trig equation using tangent. Okay. Like, were you going to use tangent? Such that we got x is equal to pi over 6. Whoa. Plus k pi. And they say k is an element of the integers. You've never seen this stuff before, so we got to talk for a second. You're getting This is big time math, okay? You're stepping it up math. So let's just analyze this guy for a second. So I got a K. That's just K. That's a plain old K. That's element of. It's like a C with that's kind of like an E, I guess. I don't know. And then this is a Z. Z for integers. Okay. Integers. But they have like a double line through it. The double line says that it's a set. And why is it Z? I think it's German. I can't remember. Like, real numbers are R, so that makes sense. We got natural numbers are N, so that makes sense. We got complex numbers is a C. That makes sense. But integers is definitely a Z. I don't know, man. I don't make this stuff up. So what are they trying to say here with all this fluff? This is the 2 pi n stuff, but rather it's like pi n, a single pi, and that's okay because remember this is tangent, so the period's only a pi. Da 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 da. Okay, so this is what they're gonna want here. Okay, they want tangent x is equal to something. It's not like that. It's something like that, but this is what you and I, need to do. This is what we want to figure out. Okay? Okay. Good. So notice that my x is going to be all this stuff here. Where is this pi over 6 tangent something or other? I don't know. Where is that stuff? Well, pi over 6 is over here at 30 degrees. Pi over 6, 30 degrees. And they're saying to add 180 every time, okay? So I'm going to add 180. So what do I get? I get over here at the 210. Or again, this would be the 7 pi over 6. And I'm going to add another 180. Okay, and add 180, add 180, da 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 da. Okay, so that's cool. That's cool. I get it. Well, let's do a little bit of like backwards math. Okay? Instead of trying to go all like, well, theoretical. I have tangent x is kind of what I need to figure out, okay? Blah blah blah. Well, what if I did x is equal to the arctangent? What if I did that instead? What if I did x equals arctangent? Of what? I don't know. But I know that x equals this stuff right here. X equals this stuff right here, okay? Now, what I'm going to do is get rid of this because it's a little bit silly. That's kind of just saying use the tangent. So I'm just going to get rid of that. I'm going to say x is equal to this guy, okay? Are we cool with that for a second? Okay. So now I need to like go backwards and solve. And so what I'm going to do is tangent both sides again. And so I got tangent of pi over 6. What is the tangent of pi over 6? What's your slope? It's the square root of 3 over 3. And so this is what you're going to write down, and then I'm going to backtrack and talk about it for a second, okay? This is what you put in GeoGebra. Tangent x, square root 3 over 3. There you go. That's it. That's your answer. And I'm going to say, done. No. Hold on. Let's just talk about it for just a second, okay? So what's happening is that my answer for pi over 6 is this, right? That's my slope. But where else does that slope exist? Down over here. Same slope, same line. But we already saw that. This here was the 30 degrees, and this here was the 210 degrees, right? I'd already said that earlier. But I'm saying now my slope is equal to square root 3 over 3, which you wrote down, right? You wrote down a little square root 3 over 3 here. A little m equals square root 3 over 3, right? Where is that happening? And so this equation basically is telling me that the answers are going to be 30 and 210 and so on and so forth. Well, isn't that what we started with? They said the answers are supposed to be 30 and 210 and stuff. So what equation are you going to get there? You're going backwards. You're going backwards. And so I know it's a little weird, but essentially I said, well, I know that the tangent's going to be this guy and this guy, and we're going to use a tangent. So just start wherever you need to start and go with it. I mean, this is basically your answer as well. I don't know if it'll take it, but there you go. Tangent equals tangent, right? X equals pi over 6. We knew that. But what was that value? Okay. I know. It's just so much. I get it. But that's why this is recorded. So that you can go back and go rewind and check things up and do whatever you need to do. But that's all I got. Thank you very much and have a great day.